Hi friends, a marvelous good afternoon to everyone. This is 𝗘𝗽𝗱𝗁 in front of you. I am studying in first year MPC. I came from TTWREIS Girls 𝗂𝗽𝗱. As a part of super student, today my subject is physics. Okay friends, before going to discuss our topic, I would like to ask some questions. Okay, can you produce electricity from magnet? Is there any relation between electricity and magnet? How the electrical appliances are work? Where we are getting electricity? Do you know anybody friends? Yes, we normally say the electrical appliances like electrical motors, generators, fans, these are all work with the help of current. But here my question is, can you produce electricity from magnet? Yes, we can produce electricity from magnet. So friends, I would like to explain with one experiment. So imagine your mind only, okay? So in this experiment, we want to require a copper coil, a bar magnet and a galvanometer. So first of all friends, take a copper coil with their endings connected to the galvanometer. Now take the bar magnet towards the coil. So when the bar magnet is towards the coil, there is a deflection on the galvanometer. Now when the bar magnet is backwards the coil, again there is a deflection on the galvanometer. When we keep it in rest, there is no deflection on the galvanometer. Okay friends, from the three observations, do you observe anything? Yes. So when the bar magnet is pushed towards the coil and pushed backwards the coil, there is a deflection on the galvanometer. The deflection of the galvanometer shows the current is induced in the conducting coil. I think friends, do you get idea about my topic? Yes. Today we are discussing about electromagnetic induction. Do you know friends what is electromagnetic induction? Yes, the electromagnetic induction is nothing but the current is generated is called induced current and it is set up by an induced electromotive force. This type of getting an induced electromotive force is called electromagnetic induction. What? Electromagnetic induction. So in simple terms, the production of electricity due to the relation between coil and magnet is also called what? Electromagnetic induction. I think friends, do you get and do you understand somewhat from this definition? So now we are going to discuss two laws. So the first law is Faraday's law and the second law is Lenz's law. So now we are going to discuss which law? Yes, Faraday's law. It is proposed by Michael Faraday in mid-19th century. To define the Faraday law of electromagnetic induction using a copper coil wound over a rod and a strong magnet. It is a very fundamental electromagnetism. It explains how the magnetic field lines will interact with electrical field circuit to produce an induced electromotive force, that is EMF. Transformers, inductors and different types of electrical motors are operating on this principle. This physical phenomena is not only allow us to gain a better understanding of our universe, but also it makes possible of technological innovations to define our modern society. Understanding the Faraday law of electromagnetic induction can be beneficial so many situations. So on the topic of Faraday law of electromagnetic induction, now we are going to discuss 4 subtopics. Okay friends, the first topic is magnetic flux. Second topic is Faraday's experimental observations. The third topic is Faraday's first law. And the last topic is as a part of Faraday law of electromagnetic induction, that is Faraday's second law. So friends, now we are going to discuss what is magnetic flux, how the flux will change. So friends, do you know anybody what is magnetic flux? Yes, the magnetic flux is nothing but the number of magnetic field lines are passing perpendicular through the surface is called magnetic flux. So now I am saying that if the stronger the magnetic field, the flux is increased. Because there is a number of magnetic field lines are passing perpendicular through the surface. So, what I am saying, if the stronger the magnetic field, the flux is also increase. So, the flux is also increase. Now, if the area of the surface is increased, then also the flux is increase. So, now I am saying that the flux is equal to BA cos theta. Do you know why I am write as BA cos theta? Because of I am saying that the flux is not always perpendicular through the surface. If it is passing with certain angle theta, then it is mutually perpendicular into two components. One is BA sin theta component and another one is BA cos theta component. Okay friends, the BA sin theta component is parallel to the surface. So that means the current is not induced in the BA sin theta component. So that's why only I am write as pi is equal to BA cos theta. This formula is useful to know the strength of the magnetic field. So this is the topic of magnetic flux. So friends, now we are going to discuss the second topic is Faraday's experimental observations. So in the Faraday's experimental observations, we see a cross symbols. So the cross symbols are indicates the number of magnetic field lines are passing inside the coil. So if the magnetic field is changed, the current is induced in the conducting coil. And if the magnetic field is constant, if the area of the surface is increased, then also the current is induced in the conducting coil. If the magnetic field and area of the surface is constant, when we rotate a conducting coil, there is an angle changing between the magnetic field and area of the loop. So then also the current is induced in the conducting coil. So from the three observations, do you observe anything guys? Yes. So the current is induced with when the magnetic field change and area of the loop is change and the theta also change. That means angle also change. Then the current is induced in the conducting coil. These are the Faraday's experimental observations. I think, do you understand what is Faraday's experimental observations? So guys, now we are going to discuss the Faraday law of electromagnetic induction. That is Faraday first law. So, do you know anybody what is Faraday first law? Yes, the Faraday first law is nothing but whenever there is a continuous change in the magnetic flux linked with conducting coil, the current is induced in the conducting coil. That means the current is flows throughout the circuit. So now I would like to explain with one experiment. So this is the galvanometer, this is the multimeter, this is the copper coil. So now I am pushed towards the magnet towards the coil. Do we see any readings in the multimeter? And there is a deflection on the galvanometer. When I keep it in rest, there is no deflection on the galvanometer as well as there is no readings showing in the multimeter. So this is the Faraday first law and this is the Faraday experiment. From the experiment, do you conclude anything? Yes, whenever there is a continuous change in the magnetic flux linked with conducting coil, the current is induced in the conducting coil. This is the statement of Faraday first law. I think, do you understand what is Faraday first law? So now we are going to discuss what is Faraday's second law. Do you know anybody what is Faraday's second law? Yes, the Faraday's second law is nothing but the magnitude of an induced current, it is proportional to the rate of change of magnetic flux. So this is the Faraday's second law. Electromagnetic force is equal to change in flux by in time intervals. So this is the formula of Faraday's second law. I think, do you understand Faraday's second law? From that, do you conclude anything? Yes. How much flux is not important. How fast the flux will changing is the important. So this is the Faraday's second law. I think friends, do you understand Faraday law of electromagnetic induction is clearly? So this is the Faraday law of electromagnetic induction. Now do you want to know what is the direction of an inducer current? So we can know the direction of inducer current through the Lenz law. Okay, do you know what is Lenz law? Yes, the Lenz law is nothing but when the electromagnetic force is set up by a coil that opposes a changes in the magnetic flux. This is the Lenz law statement. So we already know when the bar magnet is pushed towards the coil, there is a deflection on the galvanometer. That means the current is induced in the conducting coil. So we already know. So when the bar magnet is pushed towards the coil, with respect to the north pole of the coil, the current flows in clockwise direction. So the current carrying loop behaves like a magnet. So it facing south pole to the north pole of the bar magnet, then the north pole of the bar magnet attracts the coil. Do you know anybody why the bar magnet attracts the coil? Because of, we already know, unlike poles are attract each other. That why only the bar magnet attracts the coil. So our assume the clockwise direction is wrong. So the correct direction of an induced electromotive force must be in anti-clockwise direction or counterclockwise direction. So when the bar magnet is north pole to the north pole of the coil, when we push the bar magnet towards the coil, the bar magnet is repelled by the coil is repelled by the bar magnet. Why? Do you know anybody? Why the bar magnet is repelled by the coil? Because of like poles are repelled each other. We already know. That why only the like poles are repelled each other. So can you guess what is the direction of an inducer current? Yes, the direction of an inducer current is anti-clockwise direction. So this is the overall topic of Lenz law. And from that, do you understand anything? Yes. So if the current flows in clockwise direction, that side acts as a south pole of the coil. If the current flows in anti-clockwise direction, that side acts as a north pole of the coil. And this is the overall topic of Lenz law. I think do you hopefully understand what is Lenz law and what is the direction of an inducer current. So friends, do you know what is the difference between Faraday's law and Lenz law? Yes, the difference between Faraday's law and Lenz law is the Faraday's law tells us what is the current induced in the conducting coil, and Lenz law tells us what is the direction of an induced current. This is the difference between Faraday's law and Lenz law. So guys, I think you clearly understand what is the topic of electromagnetic induction is clearly through the two laws, that is Faraday's law and Lenz law. And totally I am saying that the Michael Faraday in mid-19th century proposed electromagnetic induction. It relates an induced current potential to a dynamic magnetic field. From the shining of the sun to the mobile communication, the Faraday's law has impact on our day-to-day life functions. And thank you for giving this wonderful opportunity, and thank you for cooperating me, and thank you to the Secretary sir and Principal Madam and Mentor Teacher, and lastly a special thanks to the TSAT channel. Thank you friends for giving this wonderful opportunity.